Hey, this is Braedon Williams and Dylan Bartell with our Dining Philosophers problem for 330.
Okay, so for the beginning of our program, we declare the number of philosophers, the amount that we're incrementing or decrementing the hunger each cycle, which is 1 for both. This is mostly just for debug stuff. We declare, in this case, 5-element array for determining whether the philosopher is thinking or eating, which 0 is thinking and 1 is eating. We have an array to store the philosopher's hungers. And then this array of indexes is just for initializing some threads later because we have to manage some things with addresses. Here we have a pthread mutex which functions as a lock here to make sure that we're not picking up and dropping forks at the same time, just to make sure that the logic is synchronized between the threads. And then this Boolean value is just to we signal this to become true once we're ready to stop the program. So here we have our method to pick up the forks, and this is the thread safe method. I should point out that we're not directly simulating the individual chopsticks using an array. Rather, we're just simulating the philosophers, and we're using the same logic as if there were the chopsticks, but the same logic applies to the philosophers, and it makes the program run a bit faster. So I just wanted to clarify that. So when we try to pick up the forks, we say that we indicate that with a print message. We have to engage the lock to make sure that we're not messing with stuff between threads when we shouldn't be. So we wait until we may wait to make sure no other philosophers are picking up or dropping forks. Once they are, we check, is the philosopher to the left of me eating? Or is the philosopher to the left of me thinking? And is the one to the right of me thinking? Meaning, do both of them have their chopsticks put down, which is the same logic as if we were actually simulating in the individual chopsticks. And if they're both thinking, as in they both have their chopsticks down, we say that this philosopher is ready to eat. And then we set their state to 1, which is eating. And then we leave the lock. This drop forks method is basically the same as the pickup forks method, but it just it doesn't have as much logic because they can always drop their forks. So we just wanted this to be thread safe as well. So aside from our direct philosophers, which we'll go into here, we have a waiter, which is a secondary thing that we're using for preemption to make sure that if a philosopher is about to starve, we can manage the threads to make sure that that philosopher won't actually starve. So we have an infinite loop here. For each philosopher, if that philosopher is about to die, their hunger is greater than or equal to 90. If this philosopher is hungrier than the one to the left, to the right, this is right. Just flip these. If this philosopher is hungrier than the one to its right, make the one to the right drop the forks. If this philosopher is hungrier than the one to the left, make the one to the left drop the forks. This clears things up so that we can give the highest priority to this hungry philosopher. And then we allow this philosopher to try to pick up the forks. So that's this first section of the program.
All right, so now we're on the loop that each philosopher is actually going to run, creating the philosopher with a starting hunger, main philosopher loop. This is just a failure check, checking if the philosopher's hunger reaches 100, meaning that they starve. You're counting the total system hunger. If they do reach 100, it's just going to print out that the philosopher's dead, their total hunger value. That's going to exit the program. Then the if loop, check if they're eating. If philosopher is completely full, they drop the fork. The number is represented by 0 there. That's going to print out the philosopher is full and is no longer eating. Otherwise, they're thinking, which is going to generate a random hunger chance. And they're going to try to pick up the fork. Incrementing and decrementing hunger. Decrementing. If the philosopher is not eating, their hunger increment, so they slowly start to starve. Otherwise, it's going up, and we print their hunger there. User presses a key, the program ends. I got the main philosopher loop, seeding the random number generator here.
This is the main function. We ended the main philosopher loop here. Here we have the main function we're starting.
Oh, my bad.
It's okay.
Main function, so I meant to say. Seeding the random number generator, initializing the pickup thread. And here we're creating the waiter thread, which Dylan mentioned for preemption. And creating all of the philosopher threads that for loop's just going to run through. Another for loop, don't end the program until all threads have closed. Then another for loop. At the end of the program, display all of the philosopher's hungers and the total amount of hunger in the system. That's about it.
All right, so now I'll demonstrate our program. So I'll compile it here and run it using this, which it's not immediately crashing. It's going through many loops here. And often the way that this actually works is it kind of goes up to 90 because the way that the threads work, it's a little bit difficult to synchronize them exactly in terms of time. If they are exactly synchronized to all run during the same loop, then it's actually, I don't believe, entirely possible. But just the way that it works is their hungers often end up going up a little bit, but I meant the total system hunger often goes up a little bit, but this waiter here that we have for preemption manages to always make sure that the philosophers never really go above 100, above 90 hunger. It always keeps them below that so that they don't starve. Here I'll show you another example. I'm going to press space to just stop the program after many loops have gone through to just show that it's working. And here you can see none of their hungers are actually over 90. So this demonstrates that all the philosophers are being prevented from dying and that this can run effectively forever. So thank you.